I'm going to share my screen. Right. I'm going to go here. This is week 8. Okay, this is where we are. Look, these are the videos are already there. Calculator, it's a part 3. Part 2 I've already recorded and I just hadn't put it here. Part 1 we already did together in class. Geometry is already been recorded. If you hadn't seen that video, it's there. And so the one that I'm getting ready to do is part 3, which is calculator active. And that starts with problem number 9. So go ahead and open this up right here. New window. Those of you that are in the classroom, I've already given you a copy of this sheet. Okay. This I've already pre-recorded. If we don't get to it in class, I will post the video. I will post the video this afternoon when class is over. And I'm going to start at number 9, calculator active section. This is where I'm going to start at number 9. Okay. Go to my dot cam. And we're going to start at number 9. Please make sure you have your calculator. We're going to clear it. 2nd plus 7, 1, 2. 2nd plus 7, 1, 2. We're going to start at number 9. Yes, it's the last one. Okay. Our digital interactive notebook is due Friday. If you need more time, just let me know you need more time. There's no late penalty if you turn it in on Monday. Okay. All right, here we go. Number 9, calculator active. It said, and you will need your calculator. If something goes wrong with your calculator and you need to reset, a good thing to do is you can take the batteries out and then place them back in, or you can reset the whole thing by pressing 2nd plus 7, go over to all, and then 2. Okay, and it resets everything. Okay, not just clear the memory, but it resets everything. If something goes wrong with it, this is what you would do. Okay. All right, so let's look at this one. It says, suppose that the equation, this is the equation right here, represents the value of the car from 1964 to 2002. Okay, this is a quadratic function because it has an x squared term. What year did the car have the least value? This is an upward parabola shaped like this because our A value is a positive. So it's an upward parabola. So we're looking for the minimum value, which is down here. We're looking for this vertex, okay, which is our minimum value. All right, this is what we're looking for. So in order to find that value, that X and Y value, your X is your axis of symmetry, okay? So we're going to find our AOS first, our axis of symmetry first. Might have enough space to do it here. So the formula for axis of symmetry is X is equal to negative B divided by 2A. Negative B divided by 2A. So we're going to label our A, our B, and our C, okay? So our A here is 20.8. Our B here is negative 458.3. And our C, which you won't need for axis of symmetry, but we'll label it as 3,500. So let's substitute. This gives me negative. And in parentheses, our B is negative 458.3 divided by 2 times 20.8. Okay. So let's type this in our calculator, see what we get. A negative times a negative is going to make this plus a positive here. So I'm going to type this in. We got positive 458.3 divided by, and in parentheses, we're going to multiply 2 times the 20.8 on the bottom. Okay. So type this in and see what we get. We get 11. This axis of symmetry is going to be about 11 years, or 11 point, let's put 11.01. Okay. All right. So this is my, what year did that happen? At least what year? 11 years in. Okay. So what is 11 years from then? Say again? 75. So it's going to be C. It's about 11 years afterwards. So if it's 1964, you add 11 years to that, that's going to give you about this year. Okay? Questions, comments, or concerns? Okay. All right. Let's move on. Anyone still copying? All right. Do the next one. It says the number of bacteria in a culture can be modeled by this function right here. This is a quadratic function because it has an x squared term, where T is the temperature. So T represents the temperature in degrees Celsius. The culture is being kept. The scientist wants to have fewer than 200 bacteria in the culture in order to test the medicine effectively. What is the approximate domain? Those are your X values of the temperature we have to keep the bacteria under 200, okay? To keep the bacteria under 200. All right, so we can graph this to see what this parabola is actually going to look like, okay? So let's do that. Clear. Second plus 7, 1, 2. Okay. Go to y equals and let's graph it. So we're going to type in 28 x squared minus 30 x plus 160. Okay. And we're going to see if Zoom Fit is going to give it a good window. If it doesn't, then we'll play with the window range by pressing window. But let's go to Zoom Fit first. So Zoom, and let's do Zoom Fit. Sometimes it'll give us a good coordinate plane, and sometimes it will not. Okay. All right, so here it says, let me see, let's make sure we understand. All right, so the number of bacteria in the culture can be modeled by the function. This is the equation here, it's quadratic function, where T is the temperature in degrees Celsius and the culture being kept. A scientist wants to have fewer than 200 bacteria in the culture in order to test the medicine effectively. What is the approximate domain of the temperature? So let's look at the function table instead. Let's see. Okay. And they want it to be kept under 200. Okay. So let's look to see what the values will look like under 200. All right. So let's look at it. Right now, this you see at 0 is under 200. So let me go up. Okay, look at this. This is not quite under 200. Okay, so we got to go a little bit under than that. So we know that A is not going to be our answer because that's over this amount. So this is not going to be it because X is, or T is, a negative 1.01. And look at where it is right here. Do you see that? So it should be between -1 and 0. So these are possible answers right here. Okay, these are possible answers here. And what I'm going to do to make this a little bit easier is go to table set, second window, and I'm going to type in X values. So go to X. So that way I can type in my own X values to see. Okay. Now go back to my table, second graph. So let me type in my X values. I have negative 1.01. Okay, you see how this is not under 200, so I don't want to use that one. So I got negative 0.9. Okay, this is not under 200. This is 209. So I'm type in negative 0.86. Press enter. Okay, not quite under 200. So now I got negative 0.77. And look, this is under 200. So D is going to be my answer here because this is under 200. Okay. Any questions about how I did that? Yes, baby. I sure can. I'm gonna start. You want me to start from all the way over again? Go to second. Okay, so you go second window, and do you see where it says independent? That's your X. So go down to where you see X. That means you type in your own X values and press enter. So switch from auto to X. Okay. And then when you go to table, second graph, you're able, if you don't get a clear table, just type over the numbers that are there. Okay. You're welcome. Anybody else? Okay. All right, so let's look at number 11. It says, which equation has exactly one real solution? Okay, which equation has exactly one real solution there? All right, so look, graph it to see. Okay, when it's a quadratic function, a solution means where it's going to, and this is an upward U because all these A's are positive. So it's going to be, a real solution is going to be where it crosses the x-axis. Okay, it's where it crosses the x-axis, right? So that's what the solution, and it has exactly one real solution. So that means it's only going to cross the x-axis in one place. Okay, it's going to cross it in one place. All right, so let's look to see which one of these, when we graph it, it only crosses at one place. Let's look to see. Clear it, second plus 7, 1, 2. So let's go to y equals, and let's type in this one. We have 4x squared minus 12x minus the 9. Okay. And let's graph it. So let's do zoom. You all right over there? Yeah. Okay. Zoom fit. Okay, so this one has two solutions. It crosses in two places. So this is two solutions here. Okay. All right, so let's type in the next one. We got 4x squared plus 12x plus 9. And let's do a zoom fit there. Okay, and it looks like that's not crossing at all. So let's go down on the, this is our minimum. Let's make it a -5 so we can at least see if it's crossing. I can't really see. Zoom out. Okay, is it touching only in one location? Let's see. Stat, count. Let's find. How do I do that? Or do I want to look at the table? Let's see. Let's look at the table. That might be easier for you to see. All right. So where is it crossing the let's see. When y is equal to 0. Y is still not equal to 0 there. So it doesn't look like it's touching it at all. No, it's not touching it at all. So this is no solution here. Somebody just had to call me. Oh, hold on. Okay, checking out, babe. You want to go? Yeah, I gotta do something to be checked. What does he got back first and get checked out? Oh, okay, whatever. Well, you gotta do something. Mind your business, boy. All right, here we go. Okay, so let's look at this. All right, so let's graph the next one. We got 4x to the second power by king minus 6x minus 9. Okay, so let's graph that. Zoom fit. Okay, that looks like it could be touched in one place too. Let's look at the table so we can see where y is equal to 0. Let's see, y is ever equal to 0 at all before it goes back up, and it doesn't. You don't see any place where y is 0. So it didn't even cross, it didn't cross at all. Okay, so this is another one that has no solution. Okay, so let's try this one. Four x squared plus 6x plus 9. Again, let's do zoom fit. See if it crosses. Oops, sorry. Okay, let's see. We need to go look at the table. Okay, it's going down. And then it goes back up again. So it's not touching either. So this was no solution. So that means the only one that has a real solution here is going to be the first one. It has two solutions, but there are solutions there. So your answer is going to be A. That's the best answer. None of the other ones had a solution because they did not cross the x-axis. Any questions about that one? All right, let's look at number 12. The sum of the two numbers. It doesn't say what two numbers it is, okay? So far, two numbers. One number could be x and the other number could be y. This is my first number. This is my second number so far, okay? So the sum of the two, x plus y, is equal to 24. Any questions about this? Okay. The sum of the two squares, so that means we're squaring both of these. So that's x squared plus y squared is equal to, says the sum of the two squares of the number is 306. So that's the other equation. What is the product of the two numbers? So you have to figure out what the two numbers are, okay? So let's solve for one of these numbers and basically just use substitution to figure that out. And I may need some more white paper. I probably will because I just wrote this way too big. Any questions about how I got the first or the second equation? So now I'm going to solve for this, get one of them by itself and substitute it into that other equation. So I am going to get y by itself. So let's just subtract x. So this gives me y is equal to 24 minus x. So I'm going to replace y with this expression. Okay. So here we go. We got x squared plus y squared is equal to 306. I'm going to replace y with 24 minus x. So I have 24 minus x. Any questions so far? Make sure I put that square there. So I'm going to simplify this. I'm going to simplify this first, and then I'm going to combine terms that are alike. So I'm going to push this to the side. To the side, I have 24 minus x times 24 minus x. Any questions about why I'm doing that for this? Okay. So now I'm going to do distributive property twice. I have 24 times what's in the parentheses here. Okay. And I have minus x times what's in the parentheses again. So I'm doing distributive property twice. I really wish I would have taught you guys full, because this full would have been so simpler, but that's okay. It is what it is. We didn't have time. So now we got to multiply, do distributive property twice. So good thing this is calculator active. So we got 24 times 24. That's 576. We got minus 24x. Any questions about how I got this? Okay. Then we're going to distribute this. So this gives you negative 24x. And this gives you negative times negative is positive x squared. Okay. Now I'm going to combine the terms. I'm going to combine these two in the middle. So that gives me a negative what? 48x. Okay. Bring everything else down. Please stop me if you get lost anywhere. It doesn't matter. Just stop me. I'm going to put this in order. This will go first. This x squared term goes first. Then this would be my middle term. And this would be my last. I took the sign that's in front of it, okay? So that's what I'm going to write here. This is, and just take your time on these problems. You do have plenty of time. Use your time. Okay. All right, so now I'm going to combine like terms. These two terms right here are alike. So I have 2x squared minus plus. Okay. So now, since this is a quadratic function, I need to move all the terms on the same side so that this side over here can be 0. So I always do that. When I'm solving quadratic function, it seems weird, but when you're solving a quadratic function, what you really want to know is where the parabola crosses the x-axis. And anywhere the parabola crosses the x-axis, y is always going to be 0. So that means you have to move all the variables, all the terms to the same side so that nothing's over here but 0. Y should be equal to 0. Okay. So I'm going to subtract 306 from both sides. Okay. So this is going to be 2x. And then when I subtract this, make sure I subtract it right. 576 minus 306. And that gives me a positive 27. Okay. Any questions about this? So now I need to factor that. Okay, so now I'm going to factor that. Now, an easier way to factor this is to graph it in the calculator and see where it crosses the x-axis. You could do that. Okay, and I'm going to show you, I'm going to go ahead and show you how to do that. That'll save you a lot of work with factoring. So go to y equals, type in this equation. We have 2x squared minus, we have 48x plus 270. Make sure you type that in. If I'm moving too fast, just tell me and let me know. I'll slow it down. So now I'm going to graph this. So go to Zoom Fit, see if they give us a good graph. If not, we'll switch it out. Okay, so we need to go down some. So go to Window, and we got too much space up here. You see how that's 5? Oh God, that's a lot. So go down to Y max. We don't need to go up that far. Let's just go up by, let's cut that down to 1,000. See what that gives us. And graph. See if that looks a little bit better. That's still a lot. So go back to Window. Let's do 500. And let's make this negative. Let's go down a little bit more. Let's make this negative 30. Space. Okay. All right. That's a little bit better. I still don't like the fact that it's too high. Okay. All right. So do you see this place and this place is where it crosses the x-axis. It crosses here and it crosses here as well. Okay. So I'm gonna show you in your calculator how you can get both of these values. Okay. So you're gonna go to second, trace. Gonna go where you see zeros. Just remember that's the same as finding your x-intercepts. Press enter. I'm gonna find this side over here first. Let me find my cursor. Okay. My left side, I'm gonna do above the line, and then I'm gonna do under the line. So I'm telling the calculator to search somewhere in here. Press enter. So this value right here is 9. So we got x is equal to 9. That's one of your x values. So now we're going to find the other x value over here. Okay. Do the same thing again. Press second and trace. Go to zeros. And now you're going to find the other side. So the left side on this side is going to be under the line this time and then above the line. So you're telling the calculator to search between these two places right here and press enter. So your other x value is going to be 15. Okay. Any questions about how I did that part? Okay, so it's asking for the product. So that means you need to multiply them together. So let's multiply the numbers together. And what does that give you when you multiply them together? 9 times 15 gives you 135. Okay, please don't try to do this section without your calculator. Let's do number 13. Is everybody okay with that? Okay. All right, so let's look at this one. Number 13, it says the heights of the two different projectiles after they are launched is modeled f of x, g of x. Okay, look at this. The f of x function, this is the function here. This is the equation. It's a quadratic function because it has x squared term. Okay, the table, this is the table. So they want to know the differences. It says, what is the approximate difference? That means you're going to subtract the maximum heights. Okay, So you're going to subtract the maximum heights from each other. All right, so we have an equation here, which is easy to find the maximum height here, but we need to find the maximum height of this one. Okay. All right, so this is how we find the maximum height. First, we need an equation. So go to Stat, go to Edit, and we're going to type these numbers in. We have 0, 1, 2. Go over. We have 9, 33, 25. Okay. Now we're going to do, this is a quadratic function. So we're going to go to Stat, go over to Calc, and we're going to do quadratic rig or quadratic functions. Right here's quadratic rig. And press Enter. And press Enter once more. Okay, so this is your quadratic equation here. So we're going to substitute these values in. So it's going to be y, or g of, I should probably put g of x, right? It's equal to, you got negative 16 x squared, and you got 40, this is plus 40 x, and you have 9. So, okay. This is what you have. So now you have to figure out what are the, let's see, it says, what's the difference in the maximum heights? Okay, so they're both downward parabolas. So this is what you're looking for, the differences in those heights. Okay, so you can do that in the calculator, okay? So let's do this first one. Go to y equals. Okay. And let's type this in. Negative 16 x squared plus 42 x plus 12. Okay. We're going to graph it. Go zoom fit. And we need to go up some. So go to window. I just need to go up just a little bit. Let's go up. Look at how far it goes down. That's ridiculous. Negative 500. Okay. But we need to go up some more. Let's go up to 50. Okay. All right. So we need to figure out what this top part is here. So we go to second, trace, and you're doing your maximum. Second trace is your friend. So left side of the parabola, see how I'm moving this arrow over? Okay. So I'm gonna do the left side, enter, and then I'm gonna go to the right side of the parabola because I'm telling my calculator where to search. Enter on the right side, press enter once more, and look at the maximum. The maximum height is about 39.5. So we got about 39. For this one, it's 39.5. Put 0.56. So now I'm gonna do the same thing for the second one. Okay. Go to y equals, clear it out, type in this one. Negative 16 x squared plus 40 x plus 9. Okay. Zoom is your friend. Zoom fit. Sometimes you have to finagle it a little bit because like this, look, it's hard to see the top, you know? I mean, if you're okay with it, it's fine. You press second trace and you're going to do your maximum again. Left bound is on this side of the parabola. Enter. Right bound is on the other side of the parabola. Anywhere on the other side, it doesn't matter, as long as you know it's over there. Okay, enter. You're telling the calculator to search here between those two places. Press enter. And then your maximum height is 34. This one is 34. Okay, so the differences between the two, you need to subtract. Okay, so go back to your main. So when you subtract this, you have 39.56 minus 34. So that's roughly 5.6. So that's going to be D. Okay. Any questions about that? Go to the next one. Okay. Here it's saying which expression is equivalent. So all you're going to do is just solve it. Okay. Use distributive property, combine like terms, etc., etc. So that's what we're going to do. Okay, and see if we get one of these as the answer. So we're going to simplify. So first thing is order of operations. We're going to do distributive property here. Okay, because we can't combine what's in the parentheses. So next is distributive property. Negative times a positive is a negative. It's going to give me 3x to the second power. A negative times a negative is a positive. This is going to give me 12x. Negative times a positive is a negative. This is going to give me 2x squared. A negative times a positive is a negative. This is going to give me 6x. So I did distributive property first. Now I'm going to combine terms that are alike. This term is like this term, so I'm going to combine these two together. So this gives me a negative 5x squared. Okay, so I combine those. Now I'm going to combine these two together, okay, because they're like terms. So this is going to give me a positive 6x. So my answer here is going to be this one right here, this fourth one. Okay. All right, let's look at number 15. Number 15, the length of a rectangle. So we've drawn a rectangle here. The length of it, L, is 3 inches more than the width. So that's 3 plus W. This is my width here, okay? The area of the rectangle is 40. So A is equal, to 40, all right? So now we have, what is the length in inches? So we know that the formula that we use to find area of a rectangle is length times width. So we're going to substitute the values that we know. We know that A is 40. We know that the length, or L, is 3 plus W. And we don't know what W is, so we just got times W. So to solve this, on this side to simplify, this is distributive property. Okay, so this is 40 is equal to W times 3 is 3W. W times W is W squared. Oh, so what do you know? This is a quadratic function because of this x squared. So in order to solve a quadratic function, you have to factor it. So that means everything has to be on the same side. So we're going to subtract 40 to put it over here. Okay. So now this is gone. So we're good to now factor and solve. I'm going to put this in order. The W squared goes first, then the 3W minus 4. Okay. Any questions about that?
If you have a loaner Chromebook, please turn it into the bin in the hallway at this time.
Okay, so go ahead, baby. All right, so here we look for GCF. We don't have it. We know that this is number, is Kaner microphone. Okay, it's not okay. All right, so we got W here and W here. We're gonna draw a, ooh, I'm using space that I don't need to use. So do a table, -40. What two numbers can be multiplied to give me a -40? And when I add them together, I get this middle number, a +3. Does anybody know what two numbers? What two numbers can be multiplied together to give me a -40, 8 and 5? So we got +8 times a -5. So when I add these together, I get 3, +3. So I'm going to use +8 and -5. All right. So in order to solve, I set both of these equal to 0. So this is W plus 8 is equal to 0. Subtract. And I get width is -8. Not possible, okay? Then I have W minus 5 is equal to 0. I add 5 on both sides. This is true. W is equal to 5. So my width is 5. Okay, so how do I find my length? I plug in 5 for width. So my length is going to be what? What's my length going to be? 8, because W is 5. So length is equal to 3 plus 5, which is 8. Okay. All right. Okay, any questions about that? All right. So I'm going to go ahead and give you the rest of those responses real quickly on this part. And if you have more questions about it, I'll be more than happy to help you with those. So your answers here for this one is number 2, the second one. Number 17 is this one. Number 18. Number 19. Number 20. If you haven't done these already, please make sure that you do them and that you get the correct answer. If you have questions about any of these, please come back and ask. All right, I'm gonna go ahead and stop the video at this time. Again, guys, if you have questions, please don't hesitate to ask.